All right, welcome to our very first lesson. This is lesson 1 in Math 0930, and this lesson is meant to be sort of a review of fractions. So there's a lot going on in this section. I will just say lesson 1 is not necessarily the easiest lesson, so try to be patient with yourself. There's a lot going on in this first lesson, and the ones that come after this are actually maybe not quite as full of topics. All right, so this is meant to be a review. If it's not a review for you, or if it's just been a while, just make a note of that as we're going along. Make a note of what you remember or don't remember, and please ask for help if needed. I know that fractions can be a difficult topic for many of us, and what I will say is that you're about to get better. Okay, so our first concept that we're going to do here is how to simplify or reduce fractions. There's different methods of doing this. In general, what we're going to do is cancel out common factors in the numerator and the denominator. So one way to do that is to factor each number. So I'm going to start with this number 32. And something you can do is make a factor tree. So I'll just do that off to the side here, 32. And think about how you could break down the number 32 using multiplication. So think of two numbers that multiply to 32. The first thing I thought of was 4 times 8. Maybe you thought of 2 times 16 or 8 times 4 in the other order, or maybe you just weren't really sure. That's okay. 4 times 8 is 32. Let's start there. I'm going to break down each of those into some factors. So how could I break down the number 4 using multiplication? How about 2 times 2? How could I break down the number 8? How about 2 times 4? Now I'm about to circle these number 2's because these are called prime numbers because I can't factor them anymore other than just writing 2 times 1. There's no way to factor the number 2 other than just 2 times 1. So that makes this a prime number or prime factor. Now the number 4, I'm kind of running out of space here. My tree is going to go off to the side. I can factor that into 2 times 2. Now what we have just done is something called a factor tree. These numbers that I've circled are called prime factors. So I will write that down. Prime factors. So I'm going to write out the number 32 as 2 times 2 times 2 times 2 times 2. So see how there's 5 factors of 2 just in that number 32. Now if I go ahead and do the same thing for the number 80, we can also factor that number 80. Okay, I'm going to have to erase here in a minute. So I'm going to take up some space down here in the corner, and then I'll be erasing. So hopefully you're maybe writing down maybe off to the side if you've printed this PowerPoint or in your notebook, etc. Okay, so I'm factoring the number 80. Let's see, I could use the number 2, or I could do 8 times 10. Let's see, 2 times 40. There's a lot of different ways to go with this. I think I'll start with 8 times 10, because any number that ends in 0 is a multiple of 10, so I can start there. Then I'll just keep going. 8 is 2 times 4. I know 2 is prime. I'm breaking down the number 4 into 2 times 2. Let's go over here to the 10. That would be 2 times 5. Okay, and 5 is also a prime number. I can't break it down anymore other than 5 times 1. So now I'm going to write out all the factors of 80, the prime factors of 80, I should say. So 2 times 2 times 2 times 2 times 5. So there's 4 factors of 2 and then a 5. Okay, now what I'm about to do is cancel out common factors in the numerator and the denominator. So anytime there's the same factor, the same number in the numerator and denominator, I can cancel them. Why is that? Well, anything divided by itself, 2 divided by 2, for example, is equal to 1. So I can cancel this out because 2 divided by 2 is equal to 1. So when I cross something out like this, it's not just nothing, it's 1, right? And I can do that with every pair of common factors. There's another one. And here's another one. And another one. Okay, so this essentially becomes 1 times 1 times 1 times 1 times what's left here, which is 2/5. So all this together is really 1 times the 2/5, which is just 2/5. That is our final answer. Now that was a very long, drawn out way of getting to the answer. I'm going to show you another method now. I think what I'm going to do here is actually switch my screen. There's something called a whiteboard, which is just a blank screen, and I'm going to show you a different way of reducing, and this might be the way that some of you are used to doing. Okay, so let's try same problem. Some of you might have been taught to reduce by dividing out common factors. So you might ask yourself, what do the numbers have in common? Okay, so the first thing I'm noticing here is they're both even numbers, so I can divide by 2. 32 divided by 2 is 16, 80 divided by 2 is 40. Now, when I'm doing this, I'm doing the same operation to the numerator and the denominator, but essentially, remember, anything divided by itself is 1. You're kind of just dividing by a form of 1. And that is okay. Anything divided by 1 just remains the same. So this 16 over 40 is still equal to 32 over 80. I haven't changed it. I know I've written different numbers here, but it's still technically the same. It's technically equivalent or equal. Now I'm going to do the same thing again. Let's see if we can find a common factor. Now let's not just divide by 2 over and over. If we can avoid that, can we think of a larger common factor or a greater common factor? We're going to be talking about greatest common factor here in this lesson. So the greatest common factor between 16 and 40 is actually 8. So I can get this done much more quickly. Rather than just dividing by 2 over and over again, I can divide by 8 here. 16 divided by 8 is 2. 40 divided by 8 is 5. And what I could have done at the beginning, I could have actually recognized that the GCF, the greatest common factor between 32 and 80, is actually 16. So if I divided by 16 in the numerator and the denominator, I could have gotten to this answer in one step. We're going to be doing a lot of practice with reducing. I know that was a lot just for one problem. Stick to the method that makes the most sense to you. If you'd like to write out all the factors like I did before, that's great. If you're more used to just this kind of dividing process, that's fine as well. But again, we'll continue to practice reducing. So my final answer here is 2/5. The greatest common factor between 32 and 80 turns out to be 16. And if I switch my screen back one more time, I can show you where that 16 really comes from. See these 4 2's together? 2 times 2 times 2 times 2, that was the 16, okay? So in a way, it's almost like we canceled out 16 over 16, and then we're left with the answer. All right, so are you scared yet? Just kidding, no, it's not gonna be that bad. All right, reducing fractions is something we will continue to work on. Now let's look at our next example here, multiplying. Okay, when we multiply fractions, we multiply across and reduce. Now, I'm going to show you once again 2 ways to do this. One way is to do pretty much what you're reading here, which is multiply straight across. 3 times 10 would be 30. 8 times 11, 88. So that's the multiply across part, and reduce. Okay, now I can reduce the 30 over the 88. Rather than making a factor tree like we did in our previous example, I am going to just divide. I'm not sure of the greatest common factor, but I can tell that they have a common factor of 2, so I'll start there, and if I need to keep going, that's fine. 30 divided by 2 is 15. 88 divided by 2 is 44. And if I try to break these numbers down, 15, if I break it down, it would just be 3 times 5. Neither of those numbers is a factor of 44, so I cannot find any other common factors. between these two numbers. So this is our final answer, 15 over 44. Now, if I had gone about this in a different way, we could have actually reduced first and then multiplied. So let's actually go back and do this problem again, but this time let's reduce first. So I'll rewrite it, 3/8 times 10 over 11. This time let's reduce first. Okay, what does that mean? I can't reduce 3/8 and I also can't reduce 10/11, but I can do something called cross canceling or cross reducing. I can look sort of diagonally here. Is there a number in either of the numerators that has any common factor with either of the denominators? So what we should be noticing here is actually the 10 and the 8 have a 2 in common. So if I divide them both by 2, 10 divided by 2 is 5, 8 divided by 2 is 4. So I can rewrite the problem like this. 3 over, now I have this 4 times, and now 5 over 11. And now when I multiply across, 3 times 5 is 15, 4 times 11 is 44. We end up getting the same answer as we would have gotten before. My preference will be to do this method of reducing first and then multiplying. It keeps the numbers smaller and it gets the reducing done earlier in the problem. So 30 over 88, those numbers weren't so bad, but you know, sometimes the numbers can get a little bit larger. Okay, so we've made it through our first slide. Let's move on to a couple more examples here. So some other types of operations you need to be able to do with fractions. If you can multiply, you can divide. Here is one way of wording how to do that. Keep, change, flip. That's sort of a shorthand way of saying, let's see if I can type a little additional note here. We're essentially going to be multiplying by the reciprocal, just say reciprocal, of the second fraction. Okay, so keep the first fraction the same. Change division to multiplication, and then flip, take the reciprocal of the second fraction. So that's really what that phrase means. And you may have learned other versions of that. Okay. Let's see. So what I'm going to do is rewrite the problem, keep, change, and flip. Okay, so we'll rewrite it by keeping the 12/5 the same. We're changing division to multiplication, and then we will flip or take the reciprocal of the second fraction. So the 3/7 now becomes 7 over 3. Now we can multiply across. Now, as we just saw, you can multiply across and then reduce, or let's see if we can reduce earlier. So 12 times 7, I actually might not know what that is without using a calculator. And we're not using calculators yet. So rather than doing 12 times 7, let's see if we can reduce, and then I won't have to. So what we can reduce here is the 12 with the 3. These two numbers have a 3 in common. We can divide by 3. This becomes 1. 12 divided by 3 becomes 4. So now when I rewrite this, it's 4 over 5 times 7 over 1. And then when I multiply across, 4 times 7 is 28. 5 times 1 is 5. Okay, and 5 is prime. It can't be factored at all, and it also does not go into 28. So this fraction is done. This is reduced. Now you might be noticing that it's improper. It is improper. That is okay. Unless specifically asked, it is okay to leave a fraction improper. Sometimes we will be changing improper fractions to mixed numbers, but we'll get to that later. So I'm telling you right now, this is fine for an answer, 28/5. The important thing is that it is reduced. Okay, and we'll get back to talking about improper fractions and mixed numbers a little bit later, but for now I'm going to leave this answer because I can. All right, adding and subtracting. Okay, so multiplying and dividing kind of go together. We're multiplying across, reducing. With adding and subtracting, this gets a little bit more difficult in my opinion because now we need a common denominator. The denominators need to be the same. Common just means the same. Okay, so in this example here, 4/9 plus 2/9, the common denominator is 9. So you just keep the common denominator and then you add the numerators. So 4/9 plus 2/9 is 6/9. I'm keeping the 9 as a common denominator and then adding the numerators. Now I actually can reduce. So I will reduce at the end of the problem here. There's a common factor of 3. So I can divide by 3 in the numerator and denominator. 6 divided by 3 is 2. 9 divided by 3 is 3, 2/3. Okay, so my final answer here is 2/3. But the important part I want you to see here is we had a common denominator. We kept the common denominator and we were only adding the numerators. Now there's another example. Of course, this is harder when we do not have a common denominator yet. Okay, so in our next example here, 12 and 8 obviously are not the same. So what we need to do is somehow change those numbers so that they are the same. Now, we were just reducing. This is not reducing. We are building the fractions up. So building fractions. We need to get a common denominator. How is that going to work? We need a number that is a multiple of 12 and a multiple of 8. So we actually need the least common multiple. All right, so there's different ways of doing this. I'm going to just make a list of multiples of each of these numbers. And as soon as I have a common multiple, that's the number I'll use. Okay, so multiples of 12, I'm essentially counting by 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. Let's see, is that as far as I know? 12 times 5 is 60, 12 times 6 is 72. I'm kind of running out of space here. Okay, obviously the list, oops, it's not what I meant to do. Sorry about that. The list goes on literally forever. Okay, let's do the same type of list for multiples of 8. 8, 16, 24, 32, 40, 48, etc. And it goes on. There's more. Oops. Okay, take a look at the lists that we have. Notice what is in common in those lists. There's a few numbers in common. Both lists have 24. Both lists have 48. And if I was able to keep going, both lists would also have the 72 as well. Okay, but what we want is we just want the least common denominator. So let's just use the 24 for our common denominator. Now, could we use 48? Yes, we could. Could you use 12 times 8, 96? Yes, but obviously the bigger the number you use, the more challenging it might be. Okay, so let's use 24 for our common denominator. And again, we could use 48, we could use 72, we could use 96. There's many options, but we'll stick to the least common multiple. Okay, now what we're about to do next with building fractions, it's kind of the opposite of reducing. Instead of dividing by the same number in the top and the bottom, we're about to multiply. Okay, so think about how would you change the number 12 into 24? How would we make that happen? Well, 12 times 2 is 24. Okay, so if we're multiplying the denominator by 2, we also have to multiply the numerator by 2. 5 times 2 would be 10. Okay, so when we rewrite this fraction, 5/12 would also be written as 10/24. So we're purposely building it. We're purposely rewriting it so that we have a common denominator. Okay, now let's do a similar process for the 1/8. How could we change 8 into 24? Well, you can see in our list here, it was the third number in the list, right? 8 times 3 is 24. So if I'm multiplying by 3 in the denominator, I should also multiply 3 in the numerator. 1 times 3 would be 3. That is a lot of work, okay? That's a lot of preparation work to get to this point where we can finally add. Okay, so we had to find a common denominator. I did that by making a list of multiples and then going with the least common multiple. Then we multiplied in the denominator and the numerator, the same number for both, to build our fraction up. We did that for each fraction in different ways. Our goal was to get a common denominator. This time it was 24. And finally, now we can add the numerators. 10 plus 3 would be 13. Okay, and this is our answer. Okay, good. So if there's anything we've done so far that was the most tricky, I would guess it would be the adding and subtracting. So as we're going through these, again, this is meant to be review. If it feels like a lot, maybe that just means that you need a little more review and more time with this, and that's okay. We're going to be using fractions throughout this course. So whether you like it or not, you're going to get better at them. You're going to get more comfortable with fractions. So try to just take breaks, take a deep breath. I know this is a lot for our first lesson. We're going to keep going though. Okay, so these next two slides I think are a little easier. Let me get rid of this here. Let's see. Okay. All right, so we just did an overview of operations with fractions, reducing and then multiplying, dividing, adding, and subtracting. What we're looking at now is changing between improper fractions and mixed numbers, converting from one to the other. So for improper fractions, when the numerator is larger than the denominator, right here, what we can do to change it to a mixed number is we can divide. Okay, so notice how, sorry, I'm trying to multitask here. It's not quite working. There we go. All right. Notice how, again, the numerator is bigger than the denominator, and now we're using essentially long division. It's not very long, but we're dividing. So 8/5. You can ask, what is 8 divided by 5? And it's not a whole number. How many times does 8 go, or excuse me, how many times does 5 go into 8? And it goes in one time. 1 times 5 is 5. Okay, so I might add a little extra there. And then when we subtract, our remainder is 3. Okay. So again, how many times does 5 go into 8? 1 time. 1 times 5 is 5. We can subtract. And then here's our remainder. So at one point in your life, you may have written 1 remainder 3. That's not what we're writing for our final answer. This is it, okay? So the answer, the big number on top, that's the big number in your answer, in your mixed number. The remainder, it's kind of the leftovers, that goes in the numerator of your fraction, and the denominator stays the same. Okay, so the denominator in the original problem was 5. So it is with the final answer as well. Okay, so 8/5 can be rewritten as a mixed number. It's a mixture between a whole number and a fraction. And we'd write it as 1 3/5. Okay, we're going to do an example here, 23/8. Okay. So off to the side, I'll write out my division. 23 divided by 8. How many times does 8 go into 23? Well, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. That's too big, right? I want enough factors of 8 to kind of fit inside the 23. This one would be too many. So it looks like 8 goes into 23 2 times. 2 times 8 is 16. When I subtract, I have 7 left over. So my answer here is 2 for the whole number, and then 7, that's the remainder, eighths. Okay, so again, see how the denominator is still 8, okay, and the remainder is that little number in the numerator of your answer. So 2 and 7/8. Okay, so 23/8 is equal to 2 and 7/8. Okay. Oh boy, and I realized I skipped a page. My apologies. Going backwards here. Oh dear. Okay, that's all right. It's still all getting covered. Sorry about that. All right. Mixed numbers to improper fractions. This is when we multiply and add. So what I was going to just show you right here with the problems we just did is that you could check your answer by multiplying and adding. So with 1 3/5, I could check the answer by doing 5 times 1 is 5, plus 3 is 8. 8/5, okay? So you're multiplying and adding. Same thing with this other example that we did. 2 times 8 is 16, plus 7. So 2 times 8, plus 7. 2 times 8 is 16, plus 7 is 23 over 8. So that's a way to check back to your answer. My apologies that I skipped that earlier, but let's do it right now. Changing mixed numbers to improper fractions, you're going to multiply kind of in the direction of this arrow right here. So you'll take the denominator times that whole number. So in this example, 2 3/4, I'm doing 2 times 4, and then adding the 3. Okay, so 2 times 4 is 8, plus 3 would be 11. And here's a visual for this, by the way. Let's see. Sorry. Okay. All right, sorry about that. Here's a visual. 2 3/4. Essentially, I'm attempting to illustrate the concept of fourths. Okay, so 2 of those can be colored in like this. Here's 2 whole, let's call these pizzas or pies, whatever. And then 3/4. 1, 2, 3. So look at this visual of 2 and 3/4. So there's 2 whole pies and 3/4 of a pie. If I count up all the fourths, there's 4/4 in the first one, 4/4 in the second one, and then 3/4 in the third one. If I add straight across, 4 plus 4 plus 3, that would be 11. Or there's the 2 times 4 because of these two whole pies. All right, now I've over-explained, sorry. All right, hopefully you get the idea. Let's do one quick example here. Change the mixed number to an improper fraction. All right, 5 and 2/7. Now I could write out, I could make 5 pies and divide them all into 7s. That seems a little harder. Certainly could. I'm not going to this time. Let's just follow this procedure that we saw before. 5 times 7 plus 2 is my numerator. My denominator is the same. So 5 times 7 is 35, plus 2 is 37. So 37/7 would be our improper fraction that is equivalent to this mixed number. And again, sorry for going out of order. I just hit an extra arrow on my PowerPoint, but hopefully we still got it all covered there. Okay, good. So we need to be able to do both of these things. We talked about improper to mixed numbers, and then we went back and talked about mixed to improper. Okay. Good. Let's keep going. So what's left for us to look at? We have a couple more problems to do. We're going to talk about dealing with mixed numbers essentially. So with multiplying and dividing mixed numbers, here's where we get to practice changing those mixed numbers into improper fractions first. Okay, so let's see. We have 6 3/5 divided by 5 1/4. Okay, so before we can do the keep, change, flip process, we really do need to change these mixed numbers into improper fractions. So let's do that first. 6 times 5 is 30, plus 3 is 33. So this is 33/5. I'm not ready to change the division sign yet, so I'm writing it down as it is. 5 times 4 plus 1. So 5 times 4 is 20, plus 1 is 21. Okay, so I've rewritten the problem. Now we can do keep, change, and flip. Okay, so I'm going to rewrite this now. 33/5, I keep that. I'm changing the division sign to multiplication, and now I'm flipping that second fraction. So the 21/4 is now 4 over 21. Now I will multiply across, and let's see if we can reduce along the way. 4 and 5 do not have any common factors, but 33 and 21 do have common factors. They are both multiples of 3. So I can reduce by dividing by 3. 33 divided by 3 is 11. 21 divided by 3 is 7. So I can rewrite this 11 over 5 times 4 over 7. Now I can multiply across. 11 times 4 is 44. 5 times 7 is 35. Am I done yet? Let's see. Not quite. So this fraction cannot be reduced anymore. But there's an additional instruction here. We do want the final answer as a mixed number. So we're going to divide in order to change our improper fraction back into a mixed number. So I'm going to divide 44 by 35. Okay, how many times does 35 go into 44? Just once. 35 times 2 is 70. That's way too big. So it just goes in one time. And now when we subtract, we get a remainder of 9. So our final answer is 1 and 9/35. That is our final answer. So make sure you can go back and follow all those different steps. So we had to do a lot of different skills for this one. Mixed numbers into improper. Then we did keep, change, flip for dividing. Then we reduced. We got an improper fraction as an answer. And finally, we had to change it back into a mixed number. So that's a lot of skills that we had to use for that one problem. Okay, so that was a division problem. Anytime you multiply or divide with fractions, you would have to first change the mixed numbers into improper fractions as a first step, if you happen to have mixed numbers in your problem. Okay, next, here we go. So we are adding mixed numbers. Okay, and I think, yeah, okay, good. We are adding mixed numbers and then subtracting. Okay, so I did give you one of each. All right, now you do have the option of changing mixed numbers to improper here, but with adding and subtracting, you don't actually need to. Okay, so I'm going to show you how to do this without changing them. We're going to line them up vertically. Okay, now as we do that, the whole numbers will be lined up, and then the fractions will be lined up. But you know what? I know I'm going to need a common denominator, so let's work on that here. 5 and 15 are not the same, but could I get them to be the same? Let's see. If I do 5 times 3, I could use 15 as a common denominator. So 5 times 3 is 15. 2 times 3 would be 6. So let's rewrite this. Instead of 3 2/5, I'm rewriting it as 3 6/15. Why did we do that? We did that to get a common denominator between our fractions. So 3 6/15 plus 4 11/15. Now we can add, keep the common denominator of 15, add the numerators. 6 plus 11 would be 17. And now we just get to add the whole numbers, 3 plus 4, 7. Okay, there's more. All right, it feels like we're done. There's no reducing we can do here. We didn't do anything wrong, but I'm telling you that this is not fully correct because what we have is we have a mixed number, which is fine, but within that mixed number, we have this improper fraction. This improper fraction is more than one whole. An analogy to this would be if we're talking about money, let's say you were buying something for, I don't know, $3.60 plus $4.70. It's not $7.130. That's not how that works, right? There's going to be a 1 that we need to carry. This is going to be more than $8. That's kind of what's about to happen here. Okay, so that's sort of a side example. All right, there's a dollar hidden in here. There's an extra 1. Okay, so what do we do? Well, 17/15 is improper. So let's change it to a mixed number. We can do that by dividing. 17 divided by 15 is 1 with 2 left over. So 1 2/15. Now, is that our answer? No. There's also this 7. Okay, so there was a 7 already there. Now, when we say mixed numbers, we use the word and, right? We say 7 and 17/15. The and really means that we're adding. We don't put a plus sign in here, but that's really what it is, 7 and this fraction. So my point is that we're about to add. So this 7 gets added with the 1 2/15. What we get to do is add the whole numbers. 7 plus 1 is 8 2/15. Okay, there's a lot of tricky stuff happening in that example. To avoid some of that, like I said earlier, you do have the option to change those fractions into mixed numbers, or excuse me, change the mixed numbers into improper fractions earlier if you prefer. So feel free to skip this next little part, but I'm going to quickly show you an alternative way to do this. All right, I'm going back to the whiteboard here. Do a new page. Okay, so 3, I'm going to start at this point here. 3 6/15 plus 4 11/15. Rather than keeping them lined up, if you prefer, you can change them into improper fractions. So 3 times 15 is 45, plus 6 would be 51. 4 times 15 is 60, plus 11 is 71. So see, the numbers get bigger if you do it this way, but that's okay. Still might be preferable to you. Now we add the numerators. 51 plus 71 would be 122. So 122/15, you'd now have to divide that. How many times does 15 go into 122? I don't know. So I'd have to write out my multiples of 15. So I don't know, 15 times 5 is 75. That's not big enough. Times 6 is 90. This is 105. Getting closer. I think it's going to be, oh yeah, it's going to be 8. Okay, so 15 times 8. So how many times does 15 go into 122? It would be 8 times, because 8 times 15 is 120. Here's your remainder too. So 8 2/15. Now, was this easier than the other way? Possibly yes, it was, or not. They're both challenging in their own ways. So it's okay to have more than one way to do some of these mixed number problems. And the same will be true for our very last example that we're going to go back to right now on subtracting. Okay, so last problem. We're almost there. You're doing great. Take a little stretch break if you need it. This is our last problem in this lesson. Okay, so we are subtracting with mixed numbers. We do need common denominators. So let's deal with that first. Okay, so 4 times 6 is 24. We could use 24, but actually we can use, least common denominator can be 12, because 4 times 3 is 12 times 3, and then 6 times 2 is 12 times 2. So I'm going to rewrite this problem with a common denominator, 12 and 3/12 minus 8 and 10/12. Okay, so I'm rewriting first using a common denominator of 12. Now the problem here is we are subtracting, and if I'm trying to subtract 3 minus 10, I mean, then we're into the negatives, and we know the final answer won't be negative because 12 something minus 8 something, it's not going to be negative. So what do? Well, this is where we borrow. Okay, what is that going to look like with fractions? Normally when we borrow 1. So I'm going to borrow 1 from the 12. So I'm crossing out the 12 and writing 11. Now where is that 1 going to go? You might think I'm going to write it next to this 3 and make this a 13, but we're not. We're writing it as a big whole number 1. Okay, so this is now 11 and 1 3/12. So when I rewrite that, the 1 3/12, now that gets turned into an improper fraction. So I'm purposely creating an improper fraction. I want it to be big enough so that I can subtract this 10/12. So if I rewrite it one more time, it looks like this, 11. And then let's see, 1 3/12. 12 times 1 is 12, plus 3 is 15. So it's 11 and 15/12. And finally, I can subtract the 8 and 10/12. Okay, 15 minus 10 is 5. So that's 5/12. 11 minus 8 is 3. Here is our final answer as a mixed number. Borrowing is definitely tricky stuff. When you learned about fractions in elementary school, I don't think they covered borrowing. So this, even though a lot of this may be reviewed, this part might be not feeling like review. Or even if it is, it's definitely trickier. Okay, so just like the last problem, there is an alternate way to do this. What we can do, I think I can keep it on this screen here. What we can do is we can change these mixed numbers into improper fractions. So let's kind of start at this part here with the 12 and 3/12 and 8 and 10/12. If we change those into improper, 12 times 12 is 144, plus 3 is 147. So 147/12 minus, and then 8 and 10/12, 12 times 8 is 96, plus 10 is 106. So again, see, the numbers get bigger. Okay, so that's one argument against doing it this way. The borrowing, as annoying as it might be, it does keep the numbers a little smaller. But it's up to you. Now we're going to subtract 147 minus 106. And that would be 41. Okay, so 41/12. And then finally, we need to divide to change it back into a mixed number. 12 goes into 41 3 times, because 3 times 12 is 36. And when I subtract, I get a remainder of 5. So 3 and 5/12. And see, it's the same answer either way. So it's really up to you which method you use. Okay, we've reached the end of our PowerPoint here. As we get going with our class, my plan is to have time during our Tuesday Zoom meetings to go over some MyLabs Plus examples. I will take a look at some of those right now in this video, so feel free to stop here. Or if you'd like to see just a little bit more, especially if you're new to MyLabs Plus or you've looked at the homework and found it a little tricky, that's what we're going to look at for just a couple minutes coming up right now. Okay, so I've just switched the screen. This is our list of assignments. Homework number 1 is on fractions or fractional notation. And I'd like to show you number 1 right now. Okay. And I'm making sure you can see it. Here we go. Okay. All right, so here's number 1. Let's see. You know what? It's not the one I thought it was going to be. Okay. Hang on, I'm looking ahead here. All right. Here's number 1. Okay, so this fraction right here, 18/6, we can simplify by dividing out a common factor. So there's a couple ways we can do this. We can use those factor trees that we had done before. So 2 times 9 and then 3 times 3. Those are my prime factors, right? So 2 times 3 times 3. And then 6 is just 2 times 3. Okay, and then we can cancel out our common factors. Now notice how it feels like I crossed out everything in the denominator. Remember, that just means there's only a 1 left down here. So essentially what we have here is 1 times 1 times 3. Our answer is just 3. Okay, so sometimes you do get a nice whole number for an answer. So the way I'm going to answer this is I'll put my mouse in the little box here. 3. So some students might put 3/1, and I'd like to tell you that that's not going to be accepted. You'll get this error message. Although your answer is equal to the correct answer, it's not in the correct form. So it is important to just put 3 for the final answer here.